So last time we talked about the best price you can charge, and that the best price you can charge, or the optimal price, would be a price that maximizes your profit or revenue. Revenue is a function of, profit is a function of both revenue and cost. So if you want to maximize profit, you have to take into account the cost as well, but assuming that cost is constant or is known, these two problems are the same: maximizing your revenue or profit. So the easier problem to solve is maximizing revenue, because that's what price generates revenue. We talked about having an understanding of the price demand relationship or price quantity relationship, which is a negative relationship. When one goes up, the other goes down. And we talked about the fact that the relationship usually it's a nonlinear relation. That's an example of a nonlinear relationship where the change is not constant at different price levels. And we talked about how we go about and try to create and get our own demand curve for the product we are studying. So imagine you're trying to optimize the price of a product, and you're looking for that single price that makes everything perfect for your business price-wise. We had talked about asking people indirectly or directly. Directly gives us the noisiest data. We don't learn much. It's an okay solution if you don't have anything else, but generally it's a bad solution. And we talked about field studies, which is the best solution you can come up with. In a field experiment, you basically test your different price levels, possible price levels, low end, high end, something in between, on real customers. And that's not easily doable. It's for brick and mortar businesses, it's very challenging and demanding, but for online businesses, it's more possible because of people coming from different locations, not seeing each other, not knowing what the other person is paying. So you can run a quick test and see how things are. So I wanted to show you the ZipRecruiter study that I talked about last time.
Thank you all very much for coming up.
They were charging $99. Let me quickly also bring up ZipRecruiter, what it is right now. ZipRecruiter. I hear them advertising on the radio all the time. So if I'm going to their website, this is what their website looks like. They basically matchmake employees with employers using the algorithms that they have, making the process more optimal and less costly for businesses. So they deliver value. And this professor from the University of Chicago, they were in a relationship with ZipRecruiter, working on a project, and they solved their pricing problem. So I'm going to go ahead, and this is a long presentation, and show you the relevant sections to save time. I hope the sound comes clearly across. If it doesn't, please let me know. So this is exactly what you're learning, except it's the field experiment version of it, where we're actually giving the real prices and real products to people. In our own example, we were doing a pricing survey, which is the next best solution. But the results are very similar.
ZipRecruiter.com. This is a project that's ongoing. I'm a collaborator with ZipRecruiter, along with Sanjog Misra, who some of you met on Friday at our management conference. So Sanjog just recently joined the Booth School. And so Sanjog and I have been working.
Before I continue, I got this message that audio is going in and out sporadically. This could be a particular student's problem because of their internet connection, or it could be something that all of you are experiencing because of a problem at my end. Now, is it at my end? Please type in the chat or speak up so I know what's happening. Okay, so I got one no, meaning you're hearing me clearly.
Okay, three
3 responses. Let's say audio is fine. Okay. It could be your particular audio connection or internet connection, basically. Yeah, depending on where you are, sometimes this happens. But I'm also recording this session, so the recording will also be available.
With ZipRecruiter now since last summer. And part of this engagement was to try and look for an opportunity to collaborate. This is not a consulting project. This is a research project. The terms of trade were very simple. ZipRecruiter will let us publish. I've got their CEO now, Mr. Zwelling is now on the paper, which is why I'm allowed to mention the name of the company here. Again, Mr. Zwelling is actually quite visionary, realized how are they possibly going to lose out from having their insights published in the public domain? It's not that their competitors are reading the academic journals or coming to academic investigations. And plus, he'll be already 2 years ahead of them by the time they find the paper if they do. At any rate, let me tell you a quick few things about ZipRecruiter. ZipRecruiter is the fastest growing HR company right now. They've currently got 45,000 active employers who are posting jobs on their online platform. So the way ZipRecruiter works, it's a lot like an online dating site. Recruiters come in and post jobs on the platform and they pay a fee for that service. And then the platform brings in without a fee prospective hires. And what they use is a large scale, they actually have a computer science algorithm, i.e. they use big data to try and match people. And part of what's been a success for them has been the very high quality of matches, as seen by the high repeat rates of their recruiters, not to mention a lot of their non-quantitative or text feedback, and the high conversion rates. So again, they have an algorithm they use to help recruiters find prospective employees. These jobs range from, I need somebody to drive a truck from LA to Boston, to I'm looking for a chief marketing officer. Their largest segment are starters. These are smaller companies that are a starting phase, but they've got quite a few clients who are up in the Fortune 100 as well. So they're really covering the entire gambit of recruiting and looking at jobs that range from short-term consulting to a long-term permanent employee. So we had a bunch of initial meetings with them, and the idea was to get acquainted with what it is they're doing at the organization. One of the things that came up was pricing. I teach the pricing class for the MBA program at Booth. So we had some questions about how they set prices, and it turns out they charge $99 a month for their service. So for most of their business segments, the typical fee is $99 a month. So then I came up with the super deep, highly academically based question, why $99? And actually, I was really surprised by the answer. The answer I got was, well, it used to be lower. Like, okay, well, how did you come up with the lower number? We don't really know. And they said, well, why 99? I said, well, it seemed like we were undercharging. Or why do you think you were undercharging? Oh, we don't really know. I said, okay, well, how did you come up with the price point? I said, well, originally, we looked at what other recruiting companies were charging, and we charged a small fraction of that because we figured no one will have heard of us. I'm like, okay, now you have awareness, how 99? He goes, the truth is we really have no idea. Would you be interested in helping us solve our pricing problem? I'm like, wow, sure, I would love to work on that because that's what I do, pricing. So we ran a massive experiment. And because the meeting, they have a lot of very talented people working for them. And because in the meeting, they themselves sounded kind of funny and ironic that they also couldn't figure out where their pricing was, this was an incredibly ambitious pricing experiment. So again, just to set this up here, the price experiment is very simple. For the month of September, every starter organization that came to ZipRecruiter.com that was a new client for them was randomly assigned to one of the price cells in our experiment. We ran this for an entire month. This was over at the end of the day. It was a little bit bigger than the starters. I'm just going to focus on the starters. That's 8,000 customers, business to business customers, had a price randomly assigned to them. There's actually quite a few more that were in there, as I said, but let's focus on those starters. Here's the design of the experiment. First of all, you can see we tested 10 different price levels. I apologize if this is hard to see at the back here.
Okay, I should stop here because the screen may go away. So this is a field experiment, and he will explain too, but customers come to your website in this case, and they are randomly assigned to one of these prices. So if they basically fill out the information and they hit the paywall when they have to pay, they're going to randomly see either $19 or $39 or one of these other prices. the maximum is 399. So it's a game of chance, basically. We do the randomization part because we don't want to bias the results in the favor of people who come and join at a certain time or from a certain IP. So the prices are randomly assigned. Okay, the question then becomes, when a recruiter comes and hits the paywall and sees the price of, let's say, 299, do they pay or do they leave? So the percentage of recruiters who actually pay and become a member, that percentage is called conversion rate. The percentage who have basically converted from non-customers to customers. And you can see those conversion rates here on this bar plot for different prices. So will you get more people to sign up if you charge less? If you look at my screen here and my mouse, $19 is the lowest. The answer would be yes, you're getting the highest bar. That's almost 36 or 7%. Let me see, is it 30? It's hard to see. Yes, that's 36 or 7%. Let's say 37. So if you charge $19 based on this experiment, 37% of people were actually buying. If you increase the price and go up to the most expensive price, $399, you can see that conversion or the percentage who actually purchase has come down to about 10%. 0.1 is 10%, almost. So that's the conversion rate. And you can see that we have different conversion rates for different prices. And these conversion rates basically help us build the demand curve. Let me let this person explain a little bit more. JP Doobie.
We tested monthly prices that range from as low as $19 to as high as $299. So again, it's the same service. You get, it's like a lottery, which price you get. We had the original price of 99 in there. That's going to be our control condition. And the 9 other prices we tested, think of those as the test conditions. Okay, so we tested 10 price levels and we let it rip for a month. We had 7,800 starter size firms who were in this experiment. And I've got a bar here for each of the price buckets in our experiment. And the height of the bar is the fraction of people that actually paid. The way this works is you come to their platform, you fill in a registration page. You have to do that before you can get quoted a price. If you fill in the registration page, I get tons of details about you as a firm and about your jobs that you're posting. And then you click price quote, and then you're taken to a paywall. So to be in this experiment, you had to have completed the registration and requested a price and hit the paywall. Conditional on hitting the paywall, you are then randomly assigned to one of these prices. The response rates I've got here, the conversions are, did you actually enter credit information and sign up and pay? So the data I've got here is just for the first month. Obviously, I don't have the slides on this. We continued tracking people for more than 1 month, but for the first month versus more than 1 month, main findings don't actually change that much. So as you would expect, if I charge you $19 a month, the conversion rate is going to be a lot higher than if I charge you $399 a month. But that wasn't the part that excited us about these data. What excited us about these data is the following. When I go from $99 to $299, a 4-fold increase in the price, conversion doesn't go down all that much. In fact, this surprised ZipRecruiter. They said, we would have never guessed our customers were that insensitive to the price. And my response to that is, yeah, that's exactly what happens.
So you heard the last statement. They would never guess that their customers were that insensitive to price. What did they not know? What parameter did they not know or understand about their customers? We introduced this concept last time. Please type in the chat. I'd like to see what you remember. So they didn't know how sensitive the customers were to their prices. What specific parameter were they not aware of, or they didn't know the value of that parameter? That speaks to customers' sensitivity to prices. Does anyone remember? Let me see what you remember. Please type in the chat for me, please. You can send it in direct message. You don't have to send it to everybody. Okay. So I've got 2 responses so far. What else? The rest of you are thinking. So this is the question again. They did not know anything about how sensitive their customers were to the prices. What specific parameter do they not know about? All right, now now we're talking. Keep them coming. Yeah. Okay, I got several responses. I got one, like most responses are elasticity. One response that I got so far is about willingness to pay. So they didn't know the willingness to pay. That I agree with. But the parameter that basically determines price sensitivity is the elasticity, and not elasticity alone, it's the price elasticity of demand. There are different types of elasticity. If you go into economics, because elasticity is the ratio of 2 rates of change. You can define it for anything you want. But price elasticity of demand is the elasticity between price and demand. And that they didn't know. And that's exactly what determines the shape of your demand function.
When you are not aligning the prices you're charged with the value you're delivering, right? This is just a fundamental mistake. That's step 1 of marketing. Is your pricing strategy aligned with your value proposition? This shows me it definitely wasn't. The other thing about this slide that was really fun, this part doesn't pop out, I'll just have to tell you, was before the experiment finished, we got a very enthusiastic phone call from them saying this experiment is the greatest idea. They'd never run a test like this before. I go, why is that? Well, we made a lot of money off this experiment. I go, what do you mean? Well, think about one of the main reasons why your company might not want to run an experiment. People are going to be afraid that you're going to test something really suboptimal. And because you've tested something that's a really bad idea to do in practice, you're going to lose money from that. There's an opportunity cost from the experiment. That actually didn't happen here. You can't see it from looking at this slide, although if you tabulate all the numbers, you could work it out. But if I just charged everyone $99, right, the amount of money I would have made would be 13% lower than what I got from the experiment. Why? Because it turns out that while lots of people paid $19, a lot of people also paid $249. And the experiment, I got the percentages backwards, the experimental revenues were 13% higher than what I would have got, or the company would have got that month, had they just charged $99 as usual. So yeah, we tested some suboptimal bins, but we were more than offset by that with the fact that people were willing to pay high prices. So here I'm just going to look at revenues. The unit costs are basically zero, right? There's very little cost to managing a customer on this website. Most of the costs for this business are the upfront fixed costs from investing in developing the website, and then managing the site. Per customer costs are rather negligible. So I'm just going to focus on revenues per customer. Like before, I've got the same original price we charged. Here I've got the 10 buckets of our price experiment. All I've done here is I've changed conversion on the vertical axis to their monthly revenue per customer in dollars. So you can think of this in expectation. How much money do I expect to earn per customer in each of these cells? So what it is the conversion rate times the price, right? So look at what happens in the $19 cell. I had way higher conversion, but the price is so low. This is a terrible cell. Here's where we would be normally if we just stuck with the status quo. And here we're starting getting close to the optimum. I can almost see the optimal price pop out of the picture for me.
Okay, you see what happened. This is exactly what we got out of our analysis as well. We get the demand function, but then from that we form the revenue graph, the revenue plot, and we can see a peak in the revenue near the optimal price. So in this case, for example, the optimal price would be $249 compared to the $99 they were charging. And these bars show the revenue. By the way, we call it optimally uniform price because it's a single price, just one price for the same product charged to everyone. In the interest of time, I'm going to fast forward a little bit to show you a little bit of the discussion that follows.
I don't have a slide on it, but if I was to reevaluate the experiment against the next 5 months of revenues, the optimal price would probably be about $235. Very small difference between the 1 month optimal and the 5 month optimal. The key is $99 isn't even in the ballpark. Now, what's the conceptual exercise I just went through?
Okay, you guys know what this is, right? So the price quantity or the price demand relationship, it will always be something that looks like this shape-wise, a curved, a downward sloping plot. And that's what we're basically doing. And he will basically say the same thing. This is what we got from the whole experiment, but the output of the experiment, that's what is giving us the optimal price.
I estimated a demand curve. I didn't use any statistics. I didn't use any modeling or methods. I literally just tested enough price points that the demand curve revealed itself to me. I could be an incredibly unskilled manager with no statistical background, and I can still figure out what demand looks like simply by my volition to run an experiment and test more than 1 or 2 prices. We then came up with the optimum, that $249 price, and you can see that the profitability from that price is just the area of this rectangle. It's our unit margin, price minus cost, in this case, cost is basically 0, times the number of units we would sell at that price. Now, of course, what I've just done is solved essentially ZipRecruiter's optimal uniform price problem, but why stop there?
Okay, this actually can be taken to the next step, but I don't want to go there yet. Let's first see if there are any questions. Going back to what we had, we talked about field experiments being the best way of doing it, but we also have a survey trick that we can approximate a field experiment. You did this for the soap, the steel soap, and you asked people to tell you how likely they are to buy the product at different price points. That's what we did last time in the previous session, I think. Let's see. So people answer this question. We collect the responses, but we also use some probabilities to discount or lower the weight of the responses. So we don't go out and optimistically rely on people's inaccurate responses. We become a little bit pessimistic with these probabilities. This enters our equations in the analysis itself. You just decide how likely, this depends on how optimistic you are. If someone says very likely to respond, what is the probability that they will actually go and buy if they are given the opportunity? The same for number 4. If someone says they are likely to buy, we are giving them a 20% chance of buying. And if they're on the borderline or unlikely, we give them a 0% chance of buying. So that pessimistic view gives us a more conservative estimation of the optimal price. So that's the data collection technique. Eventually, we have to determine the shape of the curve, and this is what we covered last time. When we have the shape of the curve determined, we will have that formula set up for us. You will see that in action, and you saw it in action last time. We will have the demand curve, and if you have the demand curve, finding the best price is not really challenging, because you walk on this demand curve and calculate price times quantity for every price on it. So each point on this demand curve corresponds to a single price. So this point would be here, this point would be here. So you get each of those prices multiplied by the corresponding quantity, that becomes your revenue. And then you see which one is the highest. The optimal price is giving us the best price. Yes, that's good. But should we charge only one price? You look at a company that sells something, rarely you find a company that sells only one version of their product, right? They have a product line, multiple products catering to different sections of the market or segments of the market. Look at this red dot on the screen. Can everyone see that? That middle one? Let's assume that's the optimal price. So the optimal price gives you, it's P2, price number 2. It gives you P2 times Q2, the quantity associated with it, and that's your revenue, right? So that's all you collect. And that's the pink rectangle that you see, the bigger one actually, from this point, from the red dot to the origin, that rectangle. That's your revenue. But what if you have, let's say, two other products and they charge a higher price and a lower price? Can you see how those blue and yellow rectangles are added? Those are the revenues for these products. So suddenly you go from having that pink rectangle to pink plus yellow plus blue. More revenue. With 3 different price points, you're getting more revenue. This is the core idea behind price differentiation. And if you remember, I had told you that the area under the demand curve is the revenue, right? So the more of that area you capture, the more revenue you're getting. Right here, 3 prices is getting you more area. Okay, that's great. So if I have 3 prices, I can get more area means more revenue, and that's better for the business. Perfect. Does everyone agree with me so far? Are you following? So this is called price differentiation, and there are different types of price differentiation, and I'm going to talk about it in a moment. What you just saw, those 3 prices, is called second degree. And this is the most common price differentiation technique. So with second degree, you basically give people a menu of prices. It could be 2, 3, 4, 5, 6, 7, doesn't matter. It's a finite number of prices, usually a small number, less than 10. And imagine if you had 10 red dots on this demand curve, you would basically get much, much more area than the 3 dots that you already have, right? This is called second degree price differentiation. But it's not the best actually price differentiation technique. If you can do it, if it's possible or feasible for you, first degree would be the best. What does first degree mean? Well, charge customers exactly what they are willing to pay for product. So if you're charging, let's say, a higher price of P3 here, people who would buy from you for these lower prices, they wouldn't be buying, right? P3 is too high for them. They are left out of the market. But what if you had prices all along this curve? Instead of 3 or 7 or 10, you had hundreds of prices. I don't care how much, I don't care for a simple single price. I am willing as a business to take whatever you give me. If you give me $19 for that ZipRecruiter service, that's how much it is worth to you. I'll take it. If it's 500, I'll take it. So having too many price points, or basically customized pricing, gives you access to all the area under this curve. So if you can charge everyone a different price, you would get the entire area under the curve. And that's the best, and not best, meaning the optimal, the best of the best approach. But it's not doable, right? You can't have a product and sell it to different companies at different prices, and it's the exact same product. That's not doable unless the value that you're delivering is changing. So that's why we have menus of products or customized services, customized products. And in those cases, we can try to approximate first degree price differentiation. So if you can charge anyone a single different price, do it. That's the best thing you can do in terms of pricing. If you can't, second degree can capture, let's say 70%, approximately, this is an approximate number, but 75% of the revenue you could have captured with first degree can be captured with second degree. So second degree is in a way better even, because you don't have to deal with the complexities of too many prices. You charge a few prices, but you get 70, 75, 80% of the optimal first degree differentiation revenue. So this is the most common, but when possible, companies do this. And what the presenter before, JP Dubey, was going to go ahead and tell you was that they went beyond ZipRecruiter, went beyond the uniform pricing, uniform optimal pricing, which would mean just one price. And they checked every company that came in. You filled out a form, they looked at how many, and that's how they do it now. They looked at how many employees you had, what your turnover was, how much revenue you had, and given your circumstances as a company and the value of the service to you, they will charge you a different price. So that's the best scenario, right? First degree differentiation. So they went beyond that optimization to first degree differentiation, which is optimization of optimization. So if you can do that, that's, well, definitely something you should do as a business, but we should always remember that the price differentiation, different prices, also means different service levels or different value levels. You have to give more to the customers who are paying more. And if you're charging less, it makes sense for the service to have less features in it. And that's why we have product lines and service lines. Okay, so price differentiation, sometimes it's based on product features, sometimes it's based on geography, the cost of getting the product to certain locations, time of the year. Sometimes it's based on quantity discounts, which make the price non-linear. But differentiation is the way to go. You can't go with just a uniform price. And the technique we have learned is interesting and very useful because it doesn't matter how many prices you want. Let's say you have 3 segments in your market. You did a segmentation analysis and you found 3 segments. You can do 3 separate prices and pricing studies. And the respondents in each study would be people from that segment. And you can find segment-specific optimal prices. So take a note of this if you haven't already. So you can extend the pricing study and do separate studies for people from your different target segments. That means one price study, one pricing survey for each segment. And this leads to 3 optimal prices. Make sure you take a note of that because even though our approach is simple and straightforward, it can be applied to more complex pricing scenarios. Some industries actually take pricing beyond what we talked about, and it's called revenue management or dynamic pricing, and they adjust pricing real time. There are a few of those industries, the 2 big ones being hotels and airlines. These industries basically have a high capital cost, high fixed cost, and they have resources that perishes basically if it remains unused. So for example, if the room is not occupied by a certain date and if it remains empty, that's a loss for the company. So they have to optimize price and change price real time based on the demand that comes in. So these are a little bit more sophisticated pricing schemes, and they again use the demand data just like we're using. And depending on how demand changes over time, for example, for hotels, it depends on the lead time, how many days remain until the occupancy day, and how many rooms have been occupied or reserved. Based on those profiles, they fluctuate the prices up and down until they achieve maximum occupancy. Airlines do that as well. There are a lot of flights on a daily basis, different combinations of routes. So again, those are managed by more sophisticated algorithms that optimize price in real time. So for our benefit, the takeaways is that you can optimize price to maximize revenue and profits. You can use different optimal prices for different segments, the point that I typed earlier. But you should remember that price should be aligned with value. If someone is getting more value out of the product, it makes sense to charge them more. That's why a glass of lemonade on your driveway isn't the same price as on a beach. And eventually, if you have access to demand data, you can do price management, manage your price real time. That's the ultimate optimization of price. All right, for the upcoming assignments, you're studying the fitness tracker dataset. The description of the assignments you must have downloaded. The description gives you a product and a couple of tested prices. The goal is for you to find the best price based on some survey responses. So this is an implementation of the Gabor-Granger pricing model that we went over in the previous lecture. You have a list of tested prices, and you have surveys ratings data that is in this data set, and you want to analyze it, right? Okay, so let's take a quick look at how we can do that. So as I had told you before, sometimes some bug fixes are done, and you need to reinstall this listen to data package. If you come up to the top of your analysis hub, you always have this line here, setup or update. The first time we set this up, we just did this. We installed DevTools and listen to data. That's what we did. And we also installed their dependencies. This used to be true. I changed it to false for a moment there. Their dependencies are some other packages that these two depend on. And we have to, just like prerequisites, we have to install those as well. So for this update, you don't need to update the first one. You just need to update the second one. And when you do that, you might be asked to update some other dependencies as well. I think you can ignore that. But if you want to be kind of sure about everything, just update everything. But you don't need to. You want to update just this line, and you can put your cursor anywhere, doesn't matter. Just don't select a portion. This would create an error. See, it's an error because it doesn't make sense. You're running a portion of it, which doesn't make sense. Put it everywhere, anywhere you want, and just run. And here, if I can bring up my screen. So sometimes you're going to get these additional update suggestions. These packages have more recent versions available because these are created by different people. They improve them, they fix the bugs, stuff like that. So you can try to, which one would you like to update? If you click here and type 1 here, and then hit enter, it will try to install all of them. Sometimes it fails, it doesn't matter. If you don't want to install any, you select number 3, which is none, and click here, type 3, enter none, basically run none, and you're going to install only this listen to data. So your listen to data must have been updated. The way you know that, and I cleared the screen here first, is when you run it, when you run the library to load it, in your message that you get, the welcome message, there will be a last updated timestamp, which is 11 p.m. on October 4th. This is from last night. So this is the up-to-date version. If you get this, you have the up-to-date version, and you shouldn't be getting a bug. If you're not getting this, then your version has not been updated. Okay.
Yeah, I think it's working.
All right, so perfect. So first of all, let's check for your version, make sure you have the latest version. You told me you had installed the latest version, but we were not sure if you had. So
yeah,
go
so
to,
I did.
yeah, no, not that line. Go, yeah, go to line 25. Yes, that's right. Just run it.
I don't
Alright.
get the update message.
Well, maybe you have updated before, or for some reason you're up to date. So now run the next line, please. Just click enter. Yeah. Okay. So you see this message that sometimes doesn't appear when you have already loaded the library before. So you don't get that welcome message because the library was already installed and loaded. So to double check that, can you please close your, you can save your analysis hub by clicking that floppy disk there on top left. Yeah. Yeah, save it. Okay. Now close your RStudio and reopen it, please. Don't save. You don't need to save that. It's not a big deal. Yeah, no, it doesn't matter. It just saves the variables. Okay, please reopen it. So when you run the library command for the first time, you get that welcome message. If you're doing it a couple of times, you don't get the message. So now you can run that line. Yes, line 25. Okay, so you see your last update is 11 p.m. So you have the latest version, right?
Mm-hmm.
Okay, so now let's run the analysis for you.